Thank you. So welcome. My name is Willem Veelenturf. I'm a software engineer working at Capgemini. And today I would like to talk about how we have integrated IONIC into the ING mobile banking app. So first I would like to show the ING mobile banking app. I think it's one of the best banking apps in the App Store. It has a 4-star rating. It has over 3 million installs. It is perceived as the best banking app in the Netherlands. There are even customers that switch bank to ING because they like the app so much. Also, it won multiple prizes. It has integration with the watch. It has voice and touch ID for authentication. And it has a very sophisticated authentication and encryption mechanism. So why would you integrate web technology into this beautiful app? The answer is not about the technology. It's about the people. At ING, we have 60 teams working on the ING banking app. And there are over 1,000 web developers that work on the web portals. And the list of features we would like to expand in or deliver in the app is growing and growing. Another reason is full feature teams. If you want to build full feature teams and you have a lot of different technologies in your team, so for example, you need iOS developers, you need Android developers, you need web developers, you need backend developers, a product owner and a scrum master, your team is growing very big. So if you can limit the amount of technologies to be able to deliver full features in one team, it is really helpful. So the question is, how can we enable all the web developers we have at ING to deliver features for the mobile banking app? So, I'm a big fan of IONIC. I really love how you can, as a web developer, expose your features and functionality from one single code base to multiple platforms. So, we started this journey and we were looking into the IONIC framework. And with the IONIC framework, we built the first implementation of the mobile banking app. And I would like to show you the result of that proof of concept. So basically, we did a rebuild of all the core functionality of the banking app. We did the transaction overview. We did the endless scrolling. We did a rebuild of the calendar. We even did login with Touch ID. So we were very proud because we did it all in one day. And we went back to the mobile team and we presented this. But they were quite skeptic about what we have built it because they asked questions. How does this perform on slower devices or older devices? Yes, and of course, we had to agree that it was not as fast as the native app. And what about the security layers? All the security layers we have implemented in the native app. Can you also do that in the web app? So yeah, we said, maybe we can do it, but we have to figure out. And then all the features we have built in the last 3 years, are we going to rebuild them all into IONIC technology? So basically, it was a no-go. They don't want to go the path of the IONIC app. So they basically sent us back to the drawing board. And we were thinking, is there a way that we can still expose and integrate web technology into the native app with not doing compromises on performance and have the same layers of security implemented? So we were looking into options. And we came across the Cordova framework. So we looked deeper into Cordova. What does Cordova actually do and how does it work? So, question, who has worked with Cordova here? And who knows Eddie Verbruggen? No? Ah, one there, great. Although you maybe don't know his name, but I think you have used one of his plugins, because he basically wrote 50 plugins, which is the majority of all the Cordova plugins which are out there. So in the journey where we are discovering, can we use Cordova and the plugin mechanism in the ING banking app, I also came across his name. And I thought, Eddie Verbruggen, that sounds quite Dutch to me. So I sent him an email, and he called me back, and I asked him, yeah, would you like to help us to integrate Cordova into a banking app? And he really liked the challenge. So together with Eddie, we built another proof of concept, which I would like to show you. Yeah, we were happy to do business together. So this was the second proof of concept. This time, we started from a full native app. So as you can see in this demo, the whole app is native. The top bar is native, the side menu is native, and the first screen is also native. But at the moment you click hybrid, a web view will start it with the Cordova framework, and the plugin system will be loaded. In this proof of concept, we also implemented all the security features, like SSL pinning and content encryption. So this time we went back to the mobile teams, and they were still quite skeptic, but they wanted to give it a chance. So we started our team. Our team consisted of Yoon Bai as a product owner, Eddie Verbruggen as the Cordova expert, James Rand, our performance hero, and myself as the IONIC enthusiast. We called our team Team Kit, and the purpose of our team was to build the first feature with IONIC, make guidelines for other teams, set up a build pipeline, and onboard other teams to also expose hybrid features or IONIC features into the mobile banking app. The first feature we're going to build was the feedback feature. The feedback feature is a very simple flow. It has 3 steps, but it also has some challenging integration points. For example, you should be able to directly call from the app and call into the calling functionality of the phone. We had to send the feedback via all the encryption layers of the native app. And when you finished the flow, you had to go back to the native functionality. So to be able to do that and make this experience in the app as good as possible, we had to create some Cordova plugins. And we also used some open source. So the open source plugins we used was the console plugin to be able to see all our web logs into the native log files, the device plugin to get some control over the behavior of the device, and the keyboard plugin to have a good integration with the soft keyboard of the phone. The other plugins we created I will discuss a little bit more in detail. So we wrote some plugins for experience, and the purpose of these plugins was that the experience from starting native, going to an IONIC feature, and end in the native app is as smooth as possible, and the customer should not mention that he is switching from native to web technology. So the first plugin we built was the navigation plugin. So as you see in the feedback flow, on the first screen the title says feedback, but on the second screen it says your feedback. But the title bar is a native component. So from the web features we should be able to control that title bar. Therefore we wrote this custom plugin. The same is for the hamburger icon. If you go from the first screen to the second screen, the hamburger icon should change into a back button. And the behavior of the back button should tie into the web feature. So also this plugin enables you to get control over the hamburger icon. The second feature is the dialog feature. We wanted to give the experience as close as possible to the native, and for that we decided to open all dialog boxes into the native code. So we have dialog boxes, spinners, but also the functionality to call and make use of the native calling functionality of the phone is a Cordova plugin. The third plugin we created was the Webtrekk plugin. We would like to keep track of the behavior of our customers in the app. And that should be the same also in the web features or web IONIC features we are building. So we made a plugin to be able to offload all the Webtrekk pages and events to the native layer, and there it's offloaded to the backends of ING. The last plugin we created for experience was the feature plugin, we called it. This plugin gives you control over the behavior of the feature. So to start it, to maybe pause it, and in the end, when you're on the last screen, close the feature and come back into the native app. So these were all quite easy plugins to build. The more tough plugins were the security plugins. The security plugins we have created, they were built to make sure that all the traffic from the app is as good encrypted as all the native calls in the app, from the native app. So the first plugin we created here was the HTTP plugin, which we use to send all the feedback to the APIs of ING. So every call you normally make in a web view is directly handled by the web browser. We were not able to do that because we had to send it to the native app to do all the encryption and authentication. So instead of sending it directly to the web browser, we intercept every call and we push it down to the native layer where all the authentication and encryption happens. When the package is sent to the security proxy, it's decrypted and it's handled by the APIs as a normal API call. Then the response is sent back all the way to the phone, and there you can handle it in your web view like a normal HTTP call you make in Angular. The last plugin we created was the digital PIN plugin. In some flows, you have to make an authorization for a financial or for a non-financial transaction. This is always done in a native component because of security. So we created a plugin which enables you, when you are at the fourth step of a flow and you want to do an authorization, this calls into the mobile PIN, it pops over the hybrid IONIC feature, you enter your PIN, and when you come back you get a call back and you can continue with your hybrid flow. So that brings me to the overall architecture we have created for hybrid features. We have the native app, where we integrated Cordova web views, together with all the plugins we've created and the open source plugins. On top of that, we use the Angular framework, the IONIC framework. The IONIC framework we used to get as close as possible to the native experience. All the plugins we have created, we created also Angular wrappers to make it easy for developers which develop features to control the Cordova plugins. And then on top, the features are created. In our case, we built a feedback feature. Because our goal was to enable web developers to contribute to the mobile app, we decided also to make mocks for every Cordova plugin. And the reason for that is we don't want that the web developers have to switch from developing in the browser to developing on the phone. We want to limit that only for doing an integration test. So by making mocks for all the Cordova plugins, you can, as developer, stay as long as possible in the browser, do all your testing and development there, and only when you do a confidence check when everything works as good as you think in the browser on the mobile device, you deploy it to the mobile device. So these mocks will help there. And these mocks are also very important for testing. And that's the next point. We do a lot of testing in ING. Testing is very important. And we test on multiple layers. So the first layer we test is a unit test level. So we use the Karma framework together with Jasmine to write unit tests for every controller, service, everything we create in Angular. On top of that, we also create the protractor test to test our functionality into detail. Here we test all the happy flows, but also all the non-happy flows. To validate if our features work as good as they work in the browser on the mobile phone, and also to validate if all the Cordova plugins we use in the feature work good, we also create a set of tests in the native app. The only tests we create here are the happy flows. So we deploy the features in the app, and then we run these tests to see if the integration between web and native is correct. The last testing which has been done is the manual testing, and that is done by a closed group within ING with 200 employees, and they test the version of the app for 1 week before we send it to the App Store. And then packaging. For packaging, we decided to bundle all the web features together with the app, and we did that for 2 reasons. The first reason is performance. We don't want to load all the sources over the wire before the customer is able to start a web feature. The second reason is compatibility with the Cordova plugins we created. If you decide to update the web features over the wire, you have to make sure that the API you create in Cordova and the features you ship to that device are in sync. So we don't want to go the path to build in a lot of mechanisms to do that updating over the wire, and we decided to bundle everything into one package and deploy it and deliver it to the customers via the App Store. To be able to do that, we had to do a lot of work on the build pipeline. So ING has a very advanced build pipeline for Angular apps. The build pipeline is divided in 2 phases. We have the Angular module build, which makes sure that every module that is created and built via the pipeline is tested, and there are a lot of quality toll gates before you can even deploy it into an application. The second phase of the build pipeline is the app build. Every app exists of 1 or multiple modules. The app build makes sure that everything is concatenated, optimized, aggregated, minified, and in the end packaged and shipped to Artifactory. For this project, we had to combine the web pipeline with the mobile pipeline. So we also created an app for the mobile, and I always call that the micro portal. The micro portal exists of multiple Angular modules built with IONIC, and this package is deployed into Artifactory. In the mobile build pipeline, we had to make it possible to pick up that package and bundle that into the APK and IPAs we are going to ship to the App Store. So we did a full continuous integration, continuous delivery, and combined those 2 pipelines to work together to ship all the sources to the customers. And performance. We did a lot of performance measurements in the, while we were building the feedback feature. And we saw that it was quite hard to get good performance on low-spec devices. The performance metric we were very interested in was when the moment you start a hybrid feature until, as a customer, you are ready to use it. And we saw a lot of differences there on the different devices, especially on the Samsung S2 and the iPhone 4. So we put a lot of effort also in optimizing and making that better. But in the end, on the lower devices with all browsers, it's very hard to get it performant. So we also looked in how much customers of ING still use this type of devices. And we figured out that on the low spec devices, it's less than 20% that is using them. So we decided to not put more effort in optimization of the lower devices and we accepted basically that it would never be as fast as native functionality on slower devices. We also decided we are never going to build core functionality with web technology, because the experience for the 80% of functionality you use in the app should be as good as possible, and that will always be native. So I would like to conclude this presentation with a demo of the feedback feature we have created in the last couple of months. Actually, we did the whole project in 5 months. My name is Willem Veelenturf. Thank you for listening.